Okay, let's dive right in. We're going to talk about a subject that governs literally everything you see and everything you don't, from the tiniest particle to the largest galaxy. Yep, we're talking about physics.
But forget about it as some dry school subject for a second. Instead, think about it like this. If the entire universe were a supercomputer, what would be its foundational operating system? What's the source code running the whole show? Well, that's physics.
Because at its heart, that's what physics is. It's this epic, ongoing human quest to discover the absolute, most fundamental rules that run everything. It's not just about what happens, but the deep, fundamental why of it all.
So how in the world do physicists even begin to tackle a mission that big? Well, their approach is the first part of our journey today, the quest for everything. It really boils down to this three-step dance. First, you have to describe what you see, and you do that using the precise language of mathematics. Next, you use that description to predict what's going to happen. And then, here's the Holy Grail. You try to unify all those different observations under just a few simple, elegant principles. It's a constant cycle of building and then stress testing our models of reality.
And this reveals this really cool push and pull at the heart of physics. On one hand, physicists deconstruct. They're like master mechanics, taking a complex engine apart piece by piece to see how it all works. But at the exact same time, they're trying to synthesize, to find that one master blueprint, that theory of everything that explains it all.
You know, this quest has been going on for basically all of human history, creating this incredible map of reality that keeps getting redrawn. So let's take a quick walk through that amazing history.
And look, this isn't just a boring list of dates. These are total game changers for how we see the universe. Newton comes along and bam, he realizes the same law that makes an apple fall to the ground also keeps the moon in orbit. Then Maxwell comes along and boom, another incredible unification, showing light is just an electromagnetic wave. And then the 20th century just blew the doors off everything with relativity and quantum mechanics.
And this is where we hit this massive fork in the road. You've got classical physics, which is the world you and I live in every day. It makes sense, right? It's intuitive. But then there's modern physics, and that's where things get, well, weird. It's not that Newton was wrong, not at all. It's just that his playbook didn't cover these extreme, wild conditions of the very fast and the very small.
Okay, so weird rules might sound abstract and maybe not all that useful. But here's the kicker. Those weird rules are the reason our modern world even exists. Let's see how physics literally builds the world all around you.
Let's start with the rules for the super small. It's a theory called quantum mechanics. And yeah, it's famous for being just bizarre and totally counterintuitive. But here's the thing, you're using it right now.
I mean, literally, the device you're watching this on right now, it only works because we understand quantum mechanics. The tiny transistors packed into its microchips, that's pure quantum physics. The lasers that send data across the planet, the MRI machine at the hospital that can see inside your body, the solar panels generating clean energy. Every single one is a direct result of us wrestling with this strange quantum world.
All right, so that's the tiny stuff. Now let's zoom all the way out. Let's talk about the rules for the incredibly fast and the unbelievably massive. We're talking about Einstein's theory of relativity.
And if you want the single best example of how this mind-bending theory is totally essential to your daily life, look no further than your phone's GPS. Because those satellites are moving so fast and they're in a weaker gravitational field, time literally ticks at a different rate for them, just like Einstein predicted. Without constantly correcting for his theories, your GPS would think you're kilometers away from where you actually are. It would be completely useless.
So okay, physics gives us incredible technology, that's clear. But maybe the most powerful thing it gives us is a completely new way to think, a kind of secret weapon for solving problems.
There's a reason people on Wall Street, in Silicon Valley, everywhere, love to hire physics majors. And it's not because they need someone to calculate the trajectory of a rocket. It's because a physics education basically forges this intellectual Swiss Army knife. It's a versatile tool for tackling any complex problem you can throw at it.
So how does it work? How does a physicist think? Well, it's a process. First, you learn to just strip a problem down to its bare bones, get rid of all the noise. Then you identify the fundamental rules, the first principles that are actually in charge. From there, you build a model with math, and then you solve it. See if it matches reality and test it. It's an incredibly rigorous way of thinking that you can apply to, well, pretty much anything. All right, so where is this powerful way of thinking leading us now? Let's look to the future, to the biggest unsolved mysteries on the absolute frontier of physics.
And here's maybe the biggest one of all. We look out into the universe. We see how galaxies spin, how everything's expanding. And the math just doesn't work. Our observations don't make sense unless we assume there's this invisible stuff out there. Stuff we've had to call dark matter and dark energy.
And here's the part that will absolutely blow your mind. All the stuff we know and can see, stars, galaxies, planets, you, me, everything, all of it makes up less than 5% of the entire universe. Think about that for a second. 95% of reality is completely unknown to us. We're basically living in the cosmic rounding error.
And that brings us to what is maybe the ultimate goal of modern physics. Can we finally unite our two greatest achievements? We have general relativity for all the big stuff and quantum mechanics for all the small stuff. But here's the problem. They don't work together. They're written in completely different mathematical languages. Finding a single theory of quantum gravity that unites them, well, that's the grand quest.
So, when you really look at it, from explaining the phone in your hand to questioning the very nature of existence, physics is this ultimate human adventure. It asks the biggest, the boldest, the most profound questions we can imagine. And really, the only question left is, what part of the answer will you help us find?